Hello all, welcome to this session. My name is Manish Kapoor and I am from the OCI Outbound Product Management team. I am joined by Sanjay Pillai from OCI Compute Product Management team and Peter Polyat from Ampere Computing. We are really excited to be here at ARM Developer Summit and to talk to you about Oracle's Ampere A1 based compute platform. In this session, we'll introduce you to the ARM-based Ampere A1 compute instances on Oracle Cloud Infrastructure. Next, we'll talk about some workloads that particularly work well on this platform and show you some benchmarks. Peter will then show you how easy it is to get started on A1 compute instances. We'll talk about the software ecosystem and resources available to you to start using A1 compute platform. So let's get started. Let me start with a little history about the CPUs. The CPU microarchitectures on the server side and consumer side are at an inflection point, I think. The server industry in the 1980s had a lot of CPU architectures such as x86, Spark, MIPS, and more. Over time, some of these architectures started losing the momentum, and Intel's x86 architecture became the de facto standard in most data centers. All operating systems, databases, and applications were being developed for just one CPU architecture until recently. During the same time frame, ARM became the dominant processor and the default choice for the consumer devices and mobile devices. ARM's RISC architecture results in low power consumption, and this was the primary reason for its significant adoption in the consumer segment. In the last 5 years, we have seen GPUs becoming increasingly used for high performance computing and parallel processing applications. And more recently, the ARM V8 CPUs or the ARM V8 64-bit processor architecture, and there's been a lot of innovations which have resulted in ARM CPUs coming to the server side market. In our industry, we are at a time where we'll once again see multiple CPU architectures become the norm. Customers will once again have diversity and choice in terms of building applications for different processor architectures such as ARM, x86, and GPUs. Oracle announced its first ARM-based compute offering in summer of this year, and it has been one of our most successful product launches in the recent years. Within a couple of months of launch, we have seen massive demand and a global adoption of our ARM-based compute instances, so much so that we had started running out of capacity in some of the regions, and we had to add more capacity. So let me introduce you to the Ampere A1 Compute platform. Our ARM-based offering is called the Ampere A1 Compute platform, and it is powered by 3 GHz Altra processors from Ampere Computing. We selected Ampere Altra for our ARM platform as it delivers similar performance or better performance than x86 processors for most workloads. It offers better security and at a lower price point. Let's talk a little bit about all these 3 points. Ampere's Altra processors are designed to deliver predictable performance of the scale at a scale that is required in the cloud deployments and large distributed deployments. The Altra processor has a single thread per core design that ensures that there is no contention between the core's resources. Each core has a single thread that can run at the maximum frequency of 3 GHz within its own execution engine. And this leads to predictable and consistent performance of each core. The Ampere A1 Compute platform is available as both bare metal servers as well as virtual machines. Scale and security. When it comes to A1 platform, it's powered by Altra servers, as I mentioned. It comes with 160 cores in a dual socket configuration with 1 thread per core and up to 100 Gbps of network bandwidth. The performance of the CPU scales linearly or nearly linearly as you increase the number of cores. And by running one thread per core, there is no sharing of resources across the threads. Each thread has its own registers, L1, L2 cache, and this minimizes the attack surface for exploits. It actually eliminates the potential code sharing thread security issues that we have seen with some of the other microprocessor architectures, and hence enhances the security posture of this processor. Let's talk about price performance. Oracle has introduced this industry's first 80-core ARM server, and it is being offered at only 1 cent per core hour with a flexible sizing from 1 to 80 cores and from 1 to 64 gigabytes of memory per core. At 1 cent per core hour, we believe that it provides the best price performance for many workloads. One big differentiator for Oracle's A1 platform is that we offer unique flexible virtual machine shapes that scale from 1 to 80 cores and from 1 to 64 GB of memory per core. Now, with this flexible VMs, you can select the exact number of cores and the exact amount of memory when creating or sizing your VM. This flexibility lets you build VMs that better match your workload requirements so that you can get the best price performance as well as optimize your cost based on your requirements. Let me talk a little bit about Ampere Altra processor. Ampere Altra processor was designed to meet the requirements of the modern data center and offers deterministic, consistent performance with linear scalability and at a lower power efficiency for the data centers and the hyperscale deployments. This Altra chip has 80 cores in a single socket and comes in both single and dual socket configurations, and it also supports a large cache. In fact, it has 64 KB of L1 cache and 1 MB of L2 cache and up to 192 PCIe Gen 4 lanes. Each core has one thread, unlike the hyper-threaded CPU architectures, and each core runs at the maximum frequency of 3 GHz and does not depend on turbo frequencies. This helps provide predictable and consistent performance. To improve AI inferencing, which puts a trained machine learning model into work, Ampere's Altra processor supports int8 and FP16 instruction sets, which use less processing resources than the FP32 or floating point 32 instructions. And while using this instruction set, it also provides the same level of accuracy. So it's pretty good in terms of different workloads and has a large network and I/O bandwidth as well. As I mentioned earlier, each core has a single thread, unlike most x86 CPUs that are hyper-threaded and have multiple threads per core. What this means is that each core provides an isolation and eliminates the noisy neighbor effects that we can see with some of the other architectures. And each core has its own execution engine comprising of registers, cache, and memory. So on two cores in a CPU, you could have two different workloads running in parallel, as shown here in this example. One workload, as shown here, is a database workload, and the other workload is an AI inferencing workload. Each workload can run with a predictable, consistent performance without any code sharing and without any noisy neighbor effects while providing full isolation. This leads to increased security and linear scalability of this processor. I will now pass it on to Sanjay, who will talk about workloads and how you can use Ampere A1 platform for your daily different needs. Over to you, Sanjay.
Thanks, Manish. Hey guys, I'm Sanjay Pillai from Oracle Cloud, and I'm really glad to be here at the OmDev Summit. So Manish talked a lot about the Ampere A1 platform and some of its advantages, the key technical characteristics, right? So what does that really mean, right? So when the characteristics that Manish talked about in terms of the great performance, that comes from the Ampere Ultra design, the high core count, the cache design, and of course the single-threaded consistent performance along with high memory bandwidth, we want to talk about what that translates to, right? And what that means for us with Ampere A1 is that it supports a range of different workloads, right? We don't see Ampere A1 and therefore ARM on the cloud as kind of as a niche hardware platform. It can be used everything from your web and app servers to in-memory cache systems to more intensive workloads like media encoding, AI inferencing, and then also more ARM native workloads that are mobile focused and even beyond. Um, so let's talk about some actual proof points that sort of demonstrate what I'm talking about. So web servers are probably the most common workloads that are run in the cloud today. And so ARM actually benchmarked the Nginx reverse proxy and API gateway servers on the Ampere A1 platform. And what you can see is that Ampere A1 not only performs well, but when it comes to the price performance, you can see that it has an advantage over comparable or the latest generation x86 platforms from AMD and Intel. And really, what this demonstrates is that the Ampere A1 platform is ready for your web server and your app server workloads to be run on it without fear of performance or having to kind of scale down your expectations. But let's go beyond just what web server and app workloads, right? Uh, when we think about today, the world that we're in, we are all remote, right? And media and streaming is kind of a way of life for all of us. And on Oracle Cloud, we are seeing a significant growth in the kind of media encoding, media transcoding, and streaming workloads. And ARM did benchmarking on the most popular H.264 codec encoding. And what you can see is that the Ampere A1 not only holds its own against the latest generation x86 platforms, but when you factor in the price as well, price performance as well, you can see the advantage of Ampere A1 improve over x86 platforms, right? And so what this means again is Ampere A1 should be something that every developer should consider when they are thinking about streaming or encoding applications. But the design of the Ultra processor, the single-threaded core, really starts to shine in these kind of compute-intensive workloads, as you can see on the graph on the very right. What you're seeing there is we took an 8 vCPU virtual machine across all of the different platforms, Ampere Ultra, Intel, and AMD. And what you did is what we did is we scaled the media encoding workload by using more and more threads. And what you're seeing here is that as you increase the number of threads you use for media encoding from one all the way up to 8 threads, you can see the performance scale almost linearly. In fact, it scales almost so linearly that you can see that it almost overlaps with what we call the ideal scaling, which is the dotted line. You can barely see the difference on the ampere between the ampere performance and the ideal linear scaling. Whereas on x86, the symmetric multi-threading architecture leads to a point where when you start to have to depend on both threads on the same core, you start to see the contention, and therefore the performance benefits don't linearly increase, right? And this is really where the design of the Ampere A1 or the Ultra processor really starts to benefit, because you're getting what you pay for. You literally get the performance benefit of every thread that you're able to run on a virtual machine or bare metal server, right? And one of the most common other workloads that we also see is inferencing, right? And here again, Ampere with Onspecta benchmarked their DLS, their deep learning system, the deep learning engine performance on Ampere A1 versus a comparable ARM instance on AWS, as well as a comparable Intel instance. And again, what you see on a range of different benchmarks is that in terms of price performance, the Ampere Ultra running these inferencing workloads with Onspecta provide at least a three times benefit, 3x benefit over these other platforms, sometimes higher. And so what you can see is that Ampere A1 is also where you can run your inferencing workloads without necessarily having to invest in more expensive hardware and get the same benefit. And so that really sort of almost democratizes how inferencing can be run. So for developers working in this area, Ampere A1 is something they should strongly consider. So we've talked about these proof points, but what does that? But how are we making this available to developers, right? And part of what Oracle Cloud, working with Ampere Computing, want to do is try to make ARM available to everybody, right? And so we are offering folks way to get access to Ampere A1 Compute in sort of three ways, right? The first is using the industry's sort of most generous free tier. Is you can when you sign up to use Oracle Cloud, you get 4 cores and 24 gig of memory, always free, right? And that means without having to sign up, without having to necessarily, without having to sign a contract, you're not paying for anything, but you can get 4 cores and 24 gig and a certain amount of storage, also always free. So that makes it easy for people to sort of experiment, get started without having to worry about the cost of it. In addition to this, if you sign up for our free tier account, that also gives you $300 in free credits on Oracle Cloud for 30 days. So this allows you to not only run Ampere A1 compute, but also connect to other services like Autonomous Database and a range of other Oracle services. So you can really start to build a sort of larger application. And then finally, we're also excited to introduce a new offering, the ARM Accelerator, which provides a larger amount of free credits valid for 12 months or 365 days. And what this is intended to support is large scale projects. So for open source developers, research, or EDUs, or really anybody wanting to contribute and build on ARM in the cloud, you can reach out, and we'll have links at the end to apply for the ARM Accelerator program. And we are really excited to see what we're going to be able to build using what folks who participate in this program are going to be able to build for us. And now I'd like to bring on Peter from Ampere Computing to talk about the ecosystem and also show a demonstration.
Thank you, Sanjay. So when we talk about the Ampere A1, we often get asked what software works well with the Ampere A1 platform. And both Ampere and the Oracle team have spent a lot of time curating both operating system stacks for the OCI A1 platform, as well as ensuring typical applications such as your database stacks, your container engines, Kubernetes, management platforms like Rancher, right? That they all work seamlessly on the A1. And additionally, allow you to bring your native languages like Java, Python, or Node to the A1 to run on OCI. Today, we're going to show you a demonstration. And the demonstration consists of some Terraform code that will allow you to easily get started with the Ampere A1 shapes on the Oracle Cloud. The requirements of the demonstration are quite simply the Terraform binary on your platform and an Oracle OCI always free account. The goal of the demonstration is to show supplying the minimal amount of information into the Terraform code to quickly launch and have a working Ampere A1 instance within the OCI always free environment. To keep things simple, the root compartment will be used, and the compartment ID and tenancy will be the same when launching the instances. Some additional tasks that will be performed during the demonstration will dynamically create SSH keys to use to log into the instance when we're done. We'll dynamically find the region, availability zone, and the operating system image ID to make it easier to pass into the instantiation of the virtual machine instance. We'll create the necessary core networking information and subnets to allow connectivity between virtual machine instances and externally into the virtual machine instances. We'll additionally render metadata via a Cloud Init template to pass in to the workload to establish a baseline for instance automation, configuration management. And then when we're done, we'll basically output the information to allow for easy connection back into the instances from your terminal. And if we can, here's the video of the demonstration. And what's happening here, in a typical Terraform workflow, we start with a Terraform init, which establishes the necessary components and plugins into the system, followed by a Terraform plan, which will then go through the code base and figure out what it is actually that has to be assembled within Oracle Cloud Infrastructure. And then it'll do a Terraform apply, which will actually execute and create the necessary objects within the cloud infrastructure to establish the instantiation of the A1 instance, start the A1 instances, and then inject the necessary metadata, as I mentioned earlier, to begin the automation process at the first boot of the instance. And this is what it would look like during the completion of it, outputting the necessary information to both connect and any other additional information that was dynamically generated during the creation of the instance. And now I'd like to pass it back to Manish to talk more about OCI and some of the resources available for developers.
Thank you, Peter. I love Terraform-driven automation demos. It makes it so easy to spin up instances using infrastructure as a code approach. To help developers transition, build, and run ARM-based workloads, we are enabling the community with a rich developer ecosystem of tools and resources that can make it easy for you to adopt the new platform. Let me call out 3 resources available to you to get started on the Ampere A1 Compute instances on Oracle Cloud Infrastructure. We have created an Oracle Linux developer image on ARM for ARM on OCI that provides a fast and easy way to set up a development environment in the cloud. This image includes all the development tools that you typically need and provides a complete ARM-based development environment in the cloud. It comes pre-installed with language runtimes such as Java, Python, PHP, Ruby, Node.js, and others. And it also includes the OCI, CLI, and SDKs, and also has Terraform and Ansible support needed to jumpstart your development projects. You can install this image right from the console and be up and running in just a few minutes. Next, we also have a reference architecture center that includes ARM-based reference architectures. The reference architectures can be deployed with a single click using Terraform, just like Peter demonstrated. You can run the Terraform stacks and create a full deployment architecture. For example, if you create an Apache Tomcat and Oracle database architecture, two-tier architecture, we have a Terraform script, a Terraform stack available for that on our GitHub repo, which basically will install two Tomcat servers on two Ampere A1 Compute VMs and connect with Oracle Autonomous Database in the backend. This reference architecture is all based on Terraform code. So you have the Terraform code available to you, like I said, in the GitHub repo for you to adapt these stacks for your needs and quickly get up and running with the Ampere A1 Compute instances. And third, just like most developers, I also like to use my favorite tools to develop applications on any platform. So we have partnered with a lot of ISV partners and open source communities to bring you the most commonly used developer tool chains for the Ampere A1 platform. Things like Jenkins, GitLab, SUSE Rancher, Datadog, and others. These partners have ported the solution onto Ampere A1 Compute platform. And we are continuing to invest and work with more partners to bring more tools and frameworks available to the A1 platform. You can get all these resources and more from our ARM Developer Resource Center. The URL is shown in the slide. Everything that I talked about, you can get access to those from that single URL. And here are some additional links that you can reference to. Things like Ansible collection, Terraform provider modules, and examples that are available to you to get started with the Ampere A1 Compute platform. To summarize, ARM-based server-side development opens up a lot of new opportunities for the developers to build the next generation of apps. And Ampere A1 platform offers deterministic performance, better security, and superior price performance, along with a good developer ecosystem to get you started. On this slide, I've listed several resources available to help you get started. My recommendation is to sign up for a free tier account and give it a spin, or come join our hands-on lab session where you will learn how to set up ARM-based Kubernetes clusters. Thank you for taking your time today. If you'd like to connect with us on social media, here are our social media handles. Thank you.
There's a live Q&A session starting now to continue the conversation. To take part, join us on Zoom by clicking the yellow button just below the video player on this session's page.